Hi guys, the next part that we're going to learn is polar form of complex number. We have learned on how to calculate modulus and how to calculate the argument. So we are going to use both of that information in this new form, which is known as polar form. Okay, so before we talk about that, right, let's go a bit on why in argument to find the argument we are using tan inverse B over A. This is just the idea, little bit of idea before we proceed to the next one. Why tan? Okay, so basically the idea of finding argument in this part and later in complex number will actually evolve around the properties of trigonometry, which is known as if you let me activate the pen. We have SOHCAHTOA, right? SOHCAHTOA, right? So if those are not familiar, you can follow what I'm going to say after this. SOHCAHTOA, set S here is actually for sin, cos, and tan, right? So the idea is SOH, meaning it is sine theta. To look for sine theta, it is opposite over hypotenuse. To look for cos theta, it is adjacent over hypotenuse. To look for tan, right, it is opposite over hypotenuse. So as you can see, this is SOHCAHTOA. TOA. So to put it in a form of graphic, right, you can say that in a triangle, trigonometry is always about triangle. So to look for sine, you will need opposite and opposite of the degree here, opposite over hypotenuse, which is you will need this opposite over hypotenuse. Okay, for cos, if you look for cos theta, it is adjacent to this degree, which is this adjacent over hypotenuse. As for tan, it is opposite over adjacent, right? The opposite over adjacent. So to find the theta, right, in our argument now, we are using this one, right? We want to find theta, so we are going to bring tan to the right hand side, hence it becomes theta equal to 1 over tan, or you can just put it tan inverse O over A. For our case, opposite here, right? If I were to draw a graph, right, okay, in a complex number we will always know what is A and what is B, and A is represented by the x-axis, right, this x-axis, and B will be represented by y-axis. So we are always being given the A and B, right? So the A is where you have the value of adjacent, which is this one. So this is actually the A. And then we have the opposite, which is this one, which is also equal to the y. So So we are going to have this info. So the opposite is the B, right? Our B. So it is actually, that's how we can come up with this. That's why we use tan inverse, because of the information available to us is B over A, right? That is the idea. Okay, so now let's talk about complex polar form. In polar form, okay, the idea later, the formula is Z equal to R cos theta plus J sin theta. So basically what happened is we are going to change from Z equal to A plus Bj into this form. Okay, the reason why, because later it will be useful if we are going to use some other theorem to look for the power of complex number. We're going to talk about more about that later. So how can from this form change to this form? What is the idea behind it? Also come from the SOHCAHTOA, where if you look at this, right, you'll see that, okay, for sine, S-O-H, so opposite over hypotenuse, which is this opposite over the hypotenuse. So for sine, if we are to leave it in the form of B, right, because we want to substitute this B later, okay, B will be equal to R sin theta, right? Because you remove the R to the left hand side, you will get R sin theta. So that's how you get B equal to R sin theta. So let's try just to do it again. Okay, we have Z equal to A plus Bj. So up until now we already know that B is equal to R sin theta. So I just put it here. This B here is equal to R sin theta, right? We have J in the end. And then what about A? So for A, we know that CAH is CAH, which is adjacent over hypotenuse, so adjacent over hypotenuse, or A over R. So when we change in form of A, which is R to the left hand side, you get R cos theta. So for the A, it changed to R cos theta. Alright, so Z. Basically, this is the initial form when you convert it into a polar form, which is a form that have a value of modulus and argument inside it. But if you were to simplify it a little bit more, which is you can actually pull out the R, so it becomes Z equal to R, okay, cos theta plus J sin theta. So this is where you get the polar form. Okay, now let us see in the next video on how you are going to calculate this polar form. Okay, thank you.